for section 3.5, we're looking at the fundamental theorem of algebra. What you're going to find is just now a given name of what we have already talked about. Okay, so the fundamental theorem of algebra says if f of x is a polynomial of degree n, where n is greater than 0, then f has at least one 0 in the complex number system. Okay, so from this we can derive the fact that in the complex number system, every nth degree polynomial function has precisely n zeros. Okay, and then what we're looking at here is that conjugate pairs, you know that imaginary numbers, complex numbers, occur in conjugate pairs. So for instance, if I tell you a plus bi is a root, you know that a minus bi is also a root. Okay, but reading through this, complex zeros come in conjugate pairs. Let f of x be a polynomial function that has real coefficients. If a plus bi, or b is not 0, is a 0 of the function, then the conjugate a minus bi is also a 0 of the function. So that note there, again, just reviewing that irrationals and complex roots always come in conjugate pairs. So that's like square root of 7. You also know negative square root of 7. And then the complex ones we just talked about above. A plus bi means also a minus bi. Now I just want to do one practice problem with you guys to make sure that you could do this. So notice, if I'm asking you to find the polynomial function, which we've done before, with integer coefficients that have these as the given zeros, please know I very well may likely only give you that information, because if it's 4 plus I is a root, you're supposed to know 4 minus I is also a root. Okay, so please understand that. But if I go ahead and list them out, go ahead and see what you can do with that work. Try it and then come back. All right, let's see how you did, at least starting. So you would be saying x equals those 3 zeros. Okay, turn them into factors, which means set the right side equal to 0 for each of those roots or zeros above. Turn them into factors, and then remember your job is now to multiply them out. So it's going to be easiest to keep the x minus 2 together and start with the other 3 terms by 3 terms. Remember, when you're doing 3 terms by 3 terms, you just need to be systematic. Like for instance, I'll erase these in a minute, but maybe distribute this x to all 3 of them first, and then distribute the negative 4 to all 3 of them, and then distribute the negative I to all 3 of them. So you ultimately should end up with 9 terms. Okay, so if it's an x times an I, you just want to be consistent so that you always write it the same, so that you can figure out your like terms. So I will just say if it is an x times an I write xi. Okay, all right, so try that. I have x squared minus 4x plus xi. Distributing the negative 4 would give me negative 4x plus 16 minus 4i. And distributing the negative I would give me minus xi plus 4i and minus I squared. Okay, be careful to get rid of some of the things that match with opposite signs. Looks like I've got a negative 4i and a positive 4i. And I'll keep going. So I've got x minus 2. And I really have x squared, negative 4x, so I've got negative 8x. And then 16 and negative I squared would turn into 1. So plus 17 looks like. And now just finishing up. Distribute the x to all 3 terms and the negative 2 to all 3 terms. So distributing the x, x cubed minus 8x squared plus 17x. Distributing the negative 2, negative 2x squared plus 16x minus 34. And last but not least, put it in standard form, descending power. Looks like I'll have minus 10x squared, x cubed minus 10x squared plus 33x minus 34. And that would be our final answer. Okay, remember there could be multiple answers like we've talked about before because you could get crafty. You could just multiply through by a constant, okay? But try to just keep it basic. Don't make it more complex. Just go straight for the basics. And that's all I'm looking for.